Okay. So first thing is that in these rules, you need not to memorize the rules, but it will be good if you can memorize, but there is no need. The rules which are compulsory for you to memorize is rule number 1 and rule number 5. And from my side, not from the AP side, if you can memorize rule number 6 also. These are the 3 rules which they are expecting you that you should know. AP 1 and 5, and from my side 1, 5, 6. And these are not difficult to memorize. Like first 3 rules in the red color, they're always soluble. Their solubility is very high. In rule number 1, whatever cations, anions they have mentioned, they are always soluble if they are present in any compound. So this complete family always soluble, including one more cation, ammonium. These are always soluble. Then there are some anions. One is nitrate. Remember this nitrate. It's always soluble. This is acetate, soluble. Formate. You can check your polyatomic ion list. Chlorates, perchlorates. These are the ones which are generally always soluble. This, if we can memorize, okay? We should. Then the second rule is, now as I'm going from rule number 1 to rule number 2, the solubility is decreasing. These are also always soluble, always. Except, can you see how many? Only 4 cations, 4. Silver plus, copper 1 plus, mercury 2 plus, lead 2 plus. Only 4 are not soluble. So these are the ones which are always soluble. Now rule number 3, sulfates. Sulfates are always soluble, very soluble. Except, can you check? 7. 4 are already these 4, not soluble, including 3 from here. Calcium, strontium, barium. Rest all are soluble. The complete periodic table is soluble for sulfates, except these 7. Now after that, the rule becomes very simple. Sulfides, they are always not soluble, except, this is a very simple rule. If you can memorize it, that will be good. Except first group, because they are always soluble, they are here, as well as second group. Rest complete periodic table of sulfide is insoluble. Yes, ammonium is soluble, always soluble, ammonium. This is the rule which I'm asking you to memorize. Hydroxides, OH minus. These are also always not soluble. And this is the one which we have to memorize because hydroxides are bases. We have one full unit, unit 8, which is based on acids and bases. So we should know this. And according to rule, this rule is also very simple. All are soluble, all are not soluble, except these one. These are soluble. Rest all are not soluble. Is it okay? It's easy to memorize. Ammonium, first group, and starting from calcium, they are soluble. If they are soluble, I think I discussed with you strong electrolytes and weak electrolytes, right? What are strong electrolytes? Give me 1 second why Amodita is doing quizzes, but she's not in the class. 1 second, let me remind her. One second, please. Sorry. Oh, now she's here. Okay. So please inform me if you are not joining the class so that I should not waste the time of the class. So now I was talking about, yes. So it means this first group and these one. They are always soluble. They are strong electrolytes, fully dissociated. And if they are fully dissociated, then what does it mean? They are strong bases. Agreed? Strong acids, strong bases are. So this is also telling you who all are strong bases. Strong bases are 100% dissociated. Similarly with strong acids. Remember I was using strong acid as Sa, strong electrolyte as Se. So strong acids are, strong electrolytes are 100% dissociated and are soluble. Acids are always soluble, whether they are strong or weak. See rule number 1. First group cations. So hydrogen comes in first group. They're always soluble. All acids are soluble, right? Okay, now we are moving to the next. Okay, please write down one more thing in rule number 5. We said that whoever is soluble is a strong electrolyte except ammonium hydroxide. Ammonium hydroxide is a base, but it's a weak base, which is completely soluble. Completely soluble means it is a strong electrolyte also, but still it's a weak base. So we'll understand this as we'll go for acids and bases. This is an exception. Okay, now the rule number 6. You can add one more ion here in this 1, 2, 3, one more. CrO4, 2 minus. Chromies are always not soluble except first group and ammonium. So only for the rule number 6, they are always insoluble except with this first group ammonium. Otherwise, they are insoluble. So that's the explanation of the solubility rules. Now, I'm not asking you to memorize straight away. We can practice. Yes, A, soluble, not soluble. Why? Give me the reason. So you can practice like this. Oh, it has nitrates. And yes, very good. Nitrates are always soluble. Yes, rule number 1. B, soluble, not soluble. Which rule I have to focus? I have to see rule number 2. And with chloride, bromides, and iodides, only 4 are not soluble. This copper 1 plus, not 2 plus. This and this. And please take care, this is copper 1 plus, which is very rare. So that is not soluble. But copper 2 plus is soluble. So this one is soluble. Rule number 2. This one is soluble. Rule number 1. Rubidium sulfate. Soluble, not soluble. Soluble. Rule number. Which rule you are following for this? Which rule? 1, 2, 3. Yeah, 3 and 1. 1 also. Rubidium here, first group, always soluble. Okay, now let's see D. Nickel 2 hydroxide, soluble, not soluble? Which rule number, Mayank? Rule number 5. Is it a weak base or strong base? Nickel 2 hydroxide. It's a weak base. Yes, very good. Rule number this, okay, E. Which rule number? Which is easy to memorize. Sulfides are very less soluble. Only first group and second groups are soluble. Rest all are insoluble. Yes, this is the one which is not soluble. Not soluble. Not soluble. Now, magnesium hydroxide. Which rule number? Anaya, sulfide, ide. What you are telling me is sulfite. See here, Anaya. This is sulfide. This is sulfide, T. And this is sulfate. Memorize these ions. Okay, which rule number for magnesium hydroxide? Rule number 5. Is it a strong base, weak base? Yes, it's a base, right? Hydroxide. Strong, weak. Weak base, yes. Iron 3 phosphate. Amodita, you're not answering. Iron 3 phosphate. Phosphates are always not soluble except the first group and ammonium. Not even second group, first group and ammonium. They are always not soluble. So few from my side. CuI2. Soluble, not soluble? No. What is the charge on Cu here? Is 2 plus written here? That's what I was telling you. Take care. It is Cu1 plus, not 2 plus. This one is soluble. Okay, Ane is asking how it is 2 plus. Who is going to help us? Because there are 2 iodines. Each iodine is 1 minus. It can gain 1 electron. There are 2 iodines, so 2 minus. Total minus 2. So what should be on the copper? Plus 2. Okay, CuCl. Soluble, not soluble? CuCl. This is not soluble. But if I say CuCl2, soluble, not soluble? Soluble. Very good. Okay. Now, BaCrO4. Soluble, not soluble? Not soluble. I told you to write CrO4 2 minus here. CrO4 2 minus in your list. So please take out your list because we will be in need of that list now for doing questions. Now, based on solubility rules, so these are the reactants, these two. Can you identify the reactant A and reactant B from this picture? Oh, Akash, why? From this picture. What is this? Ba2 plus. What is this? NO3 minus. So what's the reactant? So first we are going to write down the molecular equation in which we'll write down the complete formulas. So what is reactant A, children? Give me the formula with the charges. Yeah, Ba with the charges means make the formula with the help of charges. Is it soluble, not soluble? Yes, this is soluble. Now, B. What is B reactant? See, this is K plus, K plus. And what is this? Yeah, K2CrO4. Soluble, not soluble. Chromates are always not soluble except, Akash, except first group cations. K is in first group. Take out your periodic table also. Potassium is first group. They are always soluble. Rule number 1. So soluble. Now, we already know their charges, right? From here. Now you have to do the double displacement reaction. This is a double displacement. Barium will go to chromate and potassium will go to nitrate. Make the products. Double displacement reaction. Yes, double displacement reaction. Barium will go to chromate. Yes, Ananya, very good. Now, Ananya, can you tell me barium chromate soluble or not soluble? Mayank, you are very wrong in the formula of the KNO3. What's the charge on K? 1 plus. What's the charge on nitrate? I said that make the formulas using the charges, not the amount. You're looking 2 Ks, so that's why you're writing K2. You're looking 2 nitrates, you're writing NO3 2. No, there is no such formula. Mayank, you have to write the formulas looking at the charges, not at the amount. K has 1 plus, nitrate has 1 minus, so it is KNO3. KNO3, 1 is to 1. KNO3 is soluble, not okay. Barium chromate is not soluble. Very good, solid. KNO3 is soluble or not soluble? Now balance the equation. First, write the molecular equation. Second, balance the equation. Oh, yeah, it is soluble. Yes, it is soluble. Did I say not soluble? Nitrates are always soluble. Nitrates are always soluble. Okay, balance the equation, children, fast. And Mayank, you have to take care of your nitrates, 2 potassium in balancing. Now balance. How many potassiums? 2. How many nitrates? 2. What should I do to balance it? Barium is okay. Chromate is okay. This one is okay. Yes, put 2 here. This is called as molecular equation. You have to be very, very careful when you are making the formulas. You are going to make the formulas with the help of charges, not the amount. Yes, Mayank, very good. Now the next part. Now understand the next part. You know that the one which is very soluble, aqueous, is a strong electrolyte, right? And a strong electrolyte is completely dissociated in water. And the one which is solid here, the not less soluble one, this one, is a weak electrolyte. And a weak electrolyte is not dissociated. Or if it is dissociated, very less. So we have to focus on this. Okay, ready? Now I'm going to write down the complete ionic equation. Complete ionic equation. So whoever is strong electrolyte, dissociated like this, like ions. This is completely dissociated structure. This one. See, everything is dissociated here. Complete ionic reaction. This is second part. First, molecular equation. Second, complete ionic equation. Take care of the charges when you are writing the dissociation and take care of these numbers. Like this is 2, this is 1. So barium nitrate will dissociate completely like this, completely like this, to give you barium. Yes, please. 2 plus aqueous plus how many nitrates? Check. 2NO3 minus aqueous. That's the 100% dissociation of this strong electrolyte. It's a strong electrolyte. Now, K2CrO4. Is it a strong electrolyte, children? This one? Yes or no? Akash and Mayank. Why K2CrO4 is not a strong electrolyte? But now why it is a strong electrolyte? Akash, why the answer is changed? Yeah, but we have already decided that. See here what I have written. What is the meaning of this AQ? It's aqueous. Aqueous means soluble. This is aqueous, means soluble, means strong electrolyte. This is also strong electrolyte. So it means this is also dissociated completely. So please dissociate it. Amudita, are you struggling anywhere because you joined very late? Yes, Amudita. Okay. Can you dissociate this compound 100%? How many K? What is the charge on K? So they are 2K plus. Yes, like this, the way Anaya is saying. 2K plus. And how many chromates? How many chromates? Yes, Akash, very good. One chromate. CrO4. Type the charge. Charge is very important. These are the reactant. This is how they are present. Check this beaker one. Can you see all of them are completely separated as ions? 100% dissociated. Okay, now do the double displacement. The product. Is barium chromate strong electrolyte, weak electrolyte? Here is barium chromate. It's weak. So it's not 100% dissociated. So write it like this. And is this a strong electrolyte or weak electrolyte? So 2K plus aqueous and 2NO3 minus aqueous, right? Fully dissociated is aqueous, soluble, strong electrolyte. Okay, look at this complete ionic equation and give me the ions, formulas of the ions which are not undergoing any change. They are as such on the reactant side and the product side. They are not undergoing any change during the reaction. They are not participating in the reaction. They are lying there as spectators. There are two of them. Can you identify those ions which are not undergoing any change, are just lying there as spectators? Very good, Mayank. Very good. These are the spectator ions. Cancel them. This one. See, nitrate, nitrate. K plus, K plus. They are not undergoing any change. They are not participating in the reaction. They are lying as such. So we call them as spectator ions. Spectator. These are important terms which you are learning. Molecular equation, complete ionic equation, identification of spectator ions. In this equation, the spectator ions are NO3 minus and K plus. These two. Now, what is left, according to Mayank, is net ionic equation, and he's right. Net ionic, that's the real reaction. So generally, we are writing the net ionic reaction rather than the complete reaction. When you go for more higher chemistry, then your teacher will be showing you only net ionic reaction. He will not be showing you spectators because spectators are not needed for any calculation. So what is the net ionic equation? Barium 2 plus aqueous plus CrO4 2 minus aqueous, giving you barium chromate solid. So remember, in the net ionic equation, you write down somewhere. In the net ionic equation reaction, all weak electrolytes are present. Weak electrolytes, this is weak, and their ions are present, including non-electrolytes. Remember non-electrolytes? C6H12O6. Is it an electrolyte or non-electrolyte? Why? Mayank, can you explain why? You are right. Mayank is right. It's a non-electrolyte. But why? In the last class, I told you how to identify. Because it's a covalent molecule. Yes, it's a non-electrolyte. It's a covalent molecule, no moving charged particles. All of you are giving me very good language. They cannot dissociate into ions. They cannot dissociate into ions because it's not an ionic compound. It's a covalent molecule. And moving charged particles are not present because they cannot dissociate into ions. So all the three sentences, one given by Mayank, another given by Amodita, and the third given by Akash, are very good sentences. Ready for a reaction now? We'll practice more net ionic equation. Okay. Okay. I think this one we did just now. Okay, fine. So I'm taking you on the book because I think in this booklet questions are not there much. So I don't want to waste time in writing the questions. So let's pull out chapter 4 from Zumdal book. Let's do question from there. Remember, weak electrolytes, non-electrolytes, they are the part of net ionic equation. Okay. Can we do this question 44? Okay, what? Yes, Anaya. Anaya is saying that if all of them are spectator ions, then there is no reaction. And answer is yes, there is no reaction. But then why these spectator ions are needed? Why we are worried about spectator ions? Because I told you earlier also, solutions can never be charged. Solutions are never charged, right? They're always neutral. You cannot have a charged solution. So these spectator ions are maintaining the electrical neutrality. They are making your solution electrically neutral. Solutions has to be electrically neutral. They cannot be charged. So they are lying there, but they are helping in maintaining the electrical neutrality of the solution. Let's start with this question. Question 44, very fast. Pull out your solubility rules. Yes, zinc chloride, soluble, not soluble, and give me the rule number. You're going to put A, you're going to put S for soluble, not soluble, NS, and then in the last, you're going to put the rule number 1, 2, 3, 4. Zinc chloride, soluble, not soluble. And which rule number? Yes, it is soluble. And rule number 2. Very good, Amodita Mayank. Very good, Anaya. B part. Lead to nitrate. Soluble, not soluble. Yes, soluble. Rule number 1. Don't write rule, just write 1. Lead to sulfate. Soluble, not soluble. Lead to sulfate. All sulfates are soluble except 6 ions. Yes, it is soluble. We are talking about rule number 3. Sodium iodide. Soluble, not soluble. Okay. Mayank, you are wrong for the C part. D part, we soluble and rule number 1. You can say 2 also, but focus on 1 because sodium is there. Right? Mayank, you are wrong for this one. Correct yourself. Okay, cobalt 3 sulfide. Soluble, not soluble? Yes, not soluble. Rule number 4. Chromium 3 hydroxide. Soluble, not soluble? Chromium 3, not soluble. Is it a strong base and weak base? What is it? It's a weak base. You have to memorize this rule. Rule number 1, rule number 5, and 6 from my side. Magnesium carbonate. Remember all carbonates, all sulfides, all chromates are insoluble except, so not soluble. Ammonium carbonate. All ammoniums are soluble. Very good. We can memorize it, right? Good. Okay, so now I'm going to do this question, 51. And I'm not going to give you the formulas. So take out your polyatomic ion list. You should be aware of these formulas. So first, give me the charge on ammonium, formula of ammonium ion. Yes, ammonium. Very good. Then sulfate. Sulfate. Very good. Then barium. For the barium, look into the periodic table. Barium. Very good. Then nitrate. Nitrate. Very good. Perfect. Very good, dear. Okay, now we are going to make the formulas. Ammonium sulfate, barium nitrate. So what's the formula of ammonium sulfate? And we'll write the molecular equation. We are writing the molecular equation. We are going to make the formulas using the charges. And then we will see which one is soluble, which one is not soluble. Ready? Okay, ammonium sulfate. Yeah, soluble, not soluble. Which rule number? Rule number 1 as well as 3, right? Soluble. Good. Aqueous. And what's the second? Yes. BaNO3 twice. Soluble, not soluble? Soluble. Rule number 1. Now you have the charges written here. Interchange them. Do the double displacement. Do the double displacement reaction. Ammonium nitrate. Yes, the way ammonium nitrate Anaya is writing, she is writing aqueous also, means soluble, strong electrolyte. Plus, see, children, how Anaya is telling me both the things together. So which one is weak electrolyte here? Yes. Now balance the equation. Balance the equation. Add 2 here. Very good. Now you are going to split them into ions, whoever is strong. They are 3 strong. This is strong, this is strong, this is strong, this is strong because they are Aqueous. Aqueous means they are completely soluble. They are strong electrolytes. Split them. So what should I write? 2, I know the charges already now. See, ammonium. I know everything. So I'm going to split them. You can write down in your notebook and check whether I'm doing any error. And then after splitting them into ions, because they are strong electrolytes, they will be fully 100% dissociated. Identify spectator ions. See, I didn't split this one. I'm taking this as such. Yes, very good, Akash. And Mayank is telling me that spectator ions are ammonium and nitrates. Yeah, definitely they are spectators because they are always soluble. Rule number 1. So whoever is there in rule number 1 will always spectator. Am I right? All the ions of rule number 1 will be spectator ions. Okay. So what's the net ionic equation? Net ionic equation without spectator ions. Barium 2 plus sulfate 2 minus, giving you barium sulfate solid. Yes. So that's how we have to work this. So there are plenty of such problems. The booklet is already uploaded. Answers are also uploaded. So you can practice these reactions. Now I'm giving you one more. Let's do this one. Yes, Akash, they are always there. Like for the unit 1, unit 2, whatever relevant PDFs are there from the book. So generally, I'm uploading them. Their question bank, their answer sets, everything. You are not aware of that? You have never seen that books are uploaded there? So do these questions from the book. So ready for this C part? What's the formula of sodium? Sodium. So first you check the charges because don't try to do anything without writing the charges, ions on one side. So sodium, phosphate, potassium, nitrate. What's the charge on sodium, children? Potassium, phosphate. Very good. Who is this? Akash, good. Ananya, good. And nitrate, we know. Yes, nitrate. Yeah, good. Now, can you make the formula of sodium phosphate? Sodium with phosphate. Is it soluble? Write down aqueous and solid, okay? It is soluble. So Na3PO4. Rule number 1, sodiums are always soluble. Potassium, KNO3. Rule number 1, always soluble. Potassiums and nitrates are always soluble. Do the double displacement. Sodium is going to nitrate, potassium to phosphate. Write the products. Mayank. Mayank, why you are making charged particles? Why you are making NaPO4 2 minus? There is no NaPO4 2 minus. It cannot exist. It should be. You have to neutralize the charges. Mayank, you are doing error in making formulas. So you must do a quiz from unit 1. How to make formulas. See, this is PO4 3 minus. This is Na plus. So how many Nas are needed to neutralize this 3 minus? Yes, Mayank. So why you are taking only one then? and making a charge 2 minus on the top of it. Make neutral ionic compounds. Neutral. Okay. So now product side, Na is already giving me NaNO3 aqueous plus K3PO4. See, Mayank, she has taken K3 because she doesn't want to put any charge here. This is also aqueous. Any weak electrolyte here, children? So they all will remain dissociated. Let's see. Let's write down the dissociation of this. This is molecular equation. Molecular. Now let's write down complete ionic equation. Complete. So can you give me fast? Is it balanced? Before writing the complete ionic reaction, balance the equation. It's not balanced. So let's balance it. There are 3 sodiums. I need 3 here. There are 3 potassiums. I need 3. Balanced. Now, write on the complete ionic reaction. You know that who all are strong electrolytes. All ions are listed here. So it's not difficult. There are 3 sodiums, Mayank. So write 3 Na plus. This 3 will come in front. Identify the spectator ions. So what are spectator ions? See, there is 3 in front. So 3K plus, 3NO3 minus. They all are in the water, fully dissociated. On the product side, 3Na plus, 3NO3 minus. There is no weak electrolyte. So they all are going to be spectator ions. All the ions are, yes, yes. So they all cancelled out. Is there any net ionic equation? No. No reaction. See, they will give you like this. Write net ionic equation if any. So there are chances that you will get no reaction. So Mayank, can I give these questions as homework? 51, 52. These are also similar, but here the formulas are given. So I don't want you to do this because formulas are given. We'll practice how to make formulas also. So practice 51 and 52. I want to practice one more question, this one. Is it visible? Can you read it? No, 50. Which part you want to do? Pick up one part. D? Okay. Oh, this we have done, Akash, just now, barium chromate. Shall we do this A? Okay, good. Let's do A. Read the question. So here reactants are not given, but remember, both the reactants, they should be completely soluble. You cannot take one reactant as weak electrolyte. Reactants has to be strong electrolyte, completely soluble. So let's see. What should I take of Fe? What is the charge on Fe here? Work out the charge, 3 plus. What is the charge on OH? 1 minus. So I have to take a compound of Fe which is completely soluble, any compound which is completely soluble, there are many, and I have to take OH minus compound which is completely soluble. Ammonium, why? Ammonium with what? With Fe? This is 3 plus, ammonium is 1 plus. They are not going to make any compound. Am I right, Amodita? They are not interested in each other. Plus, plus. Yes, Akash is right. You can take FeCl3. There is one more probability. Fe nitrate. Take any anion from the rule number 1. Iron nitrate, iron acetate, iron hydrogen carbonate. Take any one of them from rule number 1. So I think these are popular. Chlorides. You can take bromide also, iodide also. You can take sulfates, iron sulfate, right? From rule number 1, 2, 3, you can pick up ions. Okay, so I'm taking this as the reactant. Now I need soluble OH minus. Take any cation which is completely soluble. Okay, Akash, what is this? That ammonium oxide. I need hydroxide, not oxide. And I will not be interested in ammonium because ammonium is an acidic. So don't use ammonium. Pick up something which is strong electrolyte. This is not a, this is a strong, sorry, yes, this is a strong, but it has some side reaction. You remember I said ammonium hydroxide is a weak electrolyte. Yes, take KOH. These are soluble, and then you will get FeOH3 plus 3 KNO3. I'm balancing it also. Put 3 here. And this is the one soluble, not soluble. Rule number 5. It's a weak base. It's not soluble. Then what are the spectator ions? Can you identify the spectator ions? The spectator ions must be aqueous on the reactant side and aqueous on the product side. Yes. And what is the net ionic equation? So we are not doing anything, but we are just thinking hard and working out everything without writing. What is the net ionic equation? Can you write down the net ionic equation? Yes, Akash, you are right. Ananya and Amodita is, yeah, go ahead. No, Amodita, that's wrong. You didn't place any charge on Fe. And you're writing OH and 3 in the last. See how Akash has written. Follow that. Fe has a charge of 3 plus. So you have to put ions here. Net ionic equation. And then there are 3 OH. So they will become 3 in front. You remember I was saying 3 in front. OH minus aqueous. Giving you FeOH, which is weak electrolyte. Amudita, you have seen your error? Okay, good. One more. Check your polyatomic ion list. In the last, somewhere in the last, I'm writing about a dimer. Hg2, 2 plus. Can you see this dimer in the last? It always exists like this. You cannot break it. It's always like this. So I'm trying to do this B part to make you understand why the formula is like this. Because it has to be like this only. Because it has 2 plus, that's why it needs 2 chlorides. Now, can you give me the reactant for this reaction? What reactant should I take? I need Hg2, 2 plus, the dimer, and Cl minus. Let's see. That's the solid, yeah. So I have to take some compound of Cl minus, which is completely soluble. Use rule number 1, pick up any cation from there. Yes, NaCl. You can combine this with Na plus. Completely soluble. Then you can take this cation and pick up some anion, which is always soluble. Yes, very good. Chlorate. I can do nitrate also. I can do nitrate also. Right? Now do the double displacement. You will get Hg2Cl2 solid plus NaNO3 2 aqueous. List the spectator ions, Amodita, Ananya, and Mayank. Spectator ions. Mayank, you're there? Mayank. Spectator ions, children. Okay. Yes, we need 2 in front of this. Mayank, are you there? Okay, now Ananya is asking the same question, which I try to explain here. Ananya, remember I said that look at your polyatomic ion list in the last somewhere. Can you see this dimer? Because it's always like this. It is always like this. It's going to exist like this. Okay? It's a dimer. It's a very unique cation. So please list the spectator ions, the ions which are not undergoing any change. Yes, Na plus and nitrates. Very good. Perfect. Can you now give me the net ionic equation very carefully? Please don't try to break this. It should be taken as such. Net ionic equation. So you are going to take ions of only this in the net ionic equation, right? The one which is weak electrolyte. So what's the net ionic equation, children? Yes, very good, Akash. Hg2, 2 plus and 2Cl minus, giving you Hg2Cl2. Amodita? So when you are talking about ions, you have to show charges. Meg, are we clear? Akash and Ananya has already answered it. Okay, now one more equation from my side. Remember we discussed plenty of food decomposition reactions, different types of reaction we discussed. So I'm giving you one reaction here. Ammonium carbonate is undergoing dissociation. So ammonium carbonate I have taken in aqueous form. I'm heating it very strongly, heating. But what are the products? And then we are going to write on the net ionic equation for that. So all ammonium compounds, check your notes. All ammonium compounds on decomposition gives ammonia. Yes. All carbonates gives ammonia is soluble in water because it can make hydrogen bond. But is it a electrolyte or non-electrolyte? Ammonia. Not NH3 plus. That is ammonium anaya. NH4 plus. This one is non-electrolyte. Yeah. Plus, what else is formed? I think somebody was telling me. Yes, CO2 gas. Gas. Is it a electrolyte or non-electrolyte? This one? Non-electrolyte. What else is formed? You have to balance your hydrogens. Water. Is it a electrolyte or non-electrolyte? You can call this one as weak electrolyte. Weak. Slight. Weak. Amodita. When it is pure, it's a non-electrolyte. But there is some dissociation. So just put it in the category of weak electrolyte. Balance the equation. Yes. Akash is helping me. Rest all is okay. So what is the net ionic equation? So check this. Is it a strong electrolyte, weak electrolyte? Yes, it's an electrolyte, strong electrolyte. Split it apart into ions. Okay, let's do that. So what are the ions? In ammonium carbonate, and take care of this number. I think we have to balance water also, isn't it? No, that's balanced. Yes, 2 ammonium. Who is this? Akash. Very good, Akash. And carbonate. Give me 1 second, please. So this is on the reactant side, but on the product side, do I have any strong electrolyte? No. So it will remain as such. Right? So any spectator ions here? Any spectator ions which I can cancel? Anaya, Amodita? No. So what is the net ionic equation? Same. This is also net ionic equation. There is no spectator ions. You're understanding this? Let's do one more example. You have your list of strong acids and strong bases. Can you give me one strong acid, one strong base from your list? Whoever is going to give me first, I'll take that acid and base, but it should be strong. Okay. HCl is a strong acid, means a strong electrolyte. NaOH is a strong base, means a strong electrolyte. Now do the double displacement. So check the charges on hydrogen 1 plus, Cl 1 minus, Na 1 plus, OH 1 minus. Is this NaCl soluble? This one? Okay, aqueous. Is this water a weak electrolyte or strong electrolyte? Water. Weak electrolyte. NaCl is strong electrolyte. HCl is strong electrolyte. NaOH is strong electrolyte. Now, can we write complete ionic equation? Equation is balanced. Let's go for complete ionic reaction. Hmm. Complete ionic reaction. Yes, very good. H plus, aqueous, Cl minus. Yes, very good, Akash. Anaya and Amodita. They are strong electrolytes, all of them, except water. Now, can you tell me what are the spectator ions in this? What are the spectator ions? Na plus and so what's the net ionic equation? H plus aqueous plus OH minus aqueous giving you H2O. Now, Mayank, somebody gave me that, okay, take HCl and NaOH as strong acid and strong base, and I'm writing this net ionic equation. But children, you take any strong acid, any strong base, the net ionic equation will be this only, because rest all will become spectator. So you can practice with other strong acids and strong bases also. Okay, so net ionic equation of a strong acid with strong base is this. You can pick up any strong acid, any strong base, you'll get the same answer. Only the coefficients, like it will come 2, 2 here, but you're writing in the lowest coefficient. Like if I take BaOH twice, very strong base, with the HNO3, very strong acid, I will get BaNO3 twice. Then I have to balance the equation, 2H2O, liquid. So here in this case, Ba will be spectator, NO3 will be spectator. So you're left with 2OH minus with 2H plus, giving you 2H2O. Can you see? Same net ionic equation, but you are supposed to write in lowest coefficient. So just get rid of this 2. Take out this 2. It's common. So this is very important. Keep practicing it for any competitive examination because it's not tough. So every strong acid, every strong base, whoever it is, the net ionic equation is of water. Because water is the only weak electrolyte which is formed over there. Rest all are strong. So they all become spectator. Right? Okay. Now that's about the solubility rules, net ionic equation. Now I'm going to teach you about, we have done the molarity, right? So what is molarity? Can you define molarity? Give me 2 equations of molarity. One more. Moles per liter. One more equation. I gave you, I think, last time. One more. Oh, that's the dilution law. That's the dilution law. Okay, the one which you are giving me, dilution law. Remember I said molarity can be written as millimoles over volume in milliliter. Remember this? It can be moles per liter. It can be millimoles per milliliter. Answer will be the same because moles has 1000 millimoles. Liter has 1000 milliliter. Yes, Akash. Moles, 1000 millimoles. Liter, 1000 milliliter. 1000 cancelled. You'll get this equation. So just take care of this. And children, this is capital M. It means molar, molarity. Ready for a question? 56. So when we have these type of questions, the very first thing, write down the equation, reaction, balanced reaction. In the examination, you should have these things in your mind. Okay, let me write down the balanced equation first. So one of the reactant is it soluble? Yes or no? Okay, aqueous. Other reactant is it soluble? Nitrate? Yes. Do the double displacement. But before that, you write down all the charges of the ions separately because we have not mastered these things very nicely. So we don't want to do any error in the exam. So we'll make a list of the ions. Can you give me the charges on these ions? What is the charge on Na? You can just put the charge. Yeah, +1. Phosphate, 3 minus. Lead. So check nitrate. First go for nitrate. Yeah, 2 plus. Lead is 2 plus. Meng, who is 2 minus? Your keyboard is 2 minus. Okay, good. Meng keyboard is 2 minus. Nitrate is 1 minus, right? So that's why lead is 2 plus nitrate because there are 2 nitrates. So Pb will become 2 plus. Do the double displacement, children. Make the product and identify who is the weak electrolyte. Okay, Akash is saying you will get NaNO3, which is Akash, which is soluble, and you will get Pb3PO4 2, and this is solid. Yes, Anaya. Phosphates, rule number 6. Phosphates, carbonates, sulfites, and chromates. They are least soluble except first group and ammonium. Rest all are insoluble. Rule number 6. Okay, so now this is the equation. Balance it very fast. Okay, Akash is saying put 2 here, 3 here, 6 here. Oh, I think he's right. He's good. Very good, Akash. Very fast. Okay, now read the information and what are they asking? They have given the molarity of this. Molarity is given. Molarity given. For this, molarity and volume is given. Both the things are given. If both the things are given, what do you know? Can I say you know the millimoles of this? You know the millimoles. Just rearrange this equation, this one. So, what's the answer? That millimoles is equal to molarity times volume in milliliter. Can I use this equation here to know the millimoles of this? So how many millimoles are there? 37.5. Yes, these millimoles are there. Okay, so it means this is given to me, molarity is given to me, they're asking volume. That's the question. I can use the same equation. I can get the volume if I know millimoles. Molarity is given. So who is going to help me? Millimoles over molarity. They are asking volume. Molarity they have given me. I'm using this equation in the rearranged form. So volume is millimoles over molarity. So let's do it in the form of dimensional. You start with what is given to you. 37.5 millimoles of PbNO3 twice. Convert that into millimoles of Na3PO4. Convert that into volume. Because you are working with millimoles, your answer will be in milliliter. Ready? We are doing this dimensional, Amodita, Mayank, Ananya, and you can see Akash is continuously helping me. So, very good, Akash. 37.5 millimoles of children. Can you keep checking? Can you keep confirming whether he's right or wrong? Because I'm just following what he's telling me. I had to plug in the ratio millimole to millimole from the balanced equation. I want Na3PO4, so I'll take this 2 millimoles of Na3PO4 over 3 millimoles of PbNO3 twice. Anyone has any problem here? No, we can work out the answer. Can you work with me? So this is cancelled. Now I'm going to, these are the millimoles. Now I can convert millimoles to volume if I divide it by molarity. So I'm dividing it by this molarity, which is given to me, 0.100. This is millimoles over milliliter, like this. Yes, you're right, Akash. Very good. So this is dimensional. We have set up a dimensional here, and everybody is giving me the answer as 250 ml. So I think we have understood this. I'm changing this question. If this is given to us 250 ml, this one, this is 250 ml and 0.100 molar. This is like this only. Can you tell me how much solid, the grams of the solid form, grams? Can we calculate? So Amodita is saying, why can't we use M1V1 equals to M2V2? Amodita, this is a dilution law equation. And you can use it only in the reaction when they are 1:1. Are they 1:1, Amodita? If you want to use this equation, use this. M1V1. Children, pay attention. I'm teaching something new. I cannot use this equation here because my moles are not equal. This means moles are equal. I cannot use. So what I can do that I can modify the equation, which I'm not advising. AP is not into it. You divide this by 2, M1V1 by 2, this coefficient, and this one by 3. Then you can use. Now if you use this equation, you will get the same answer, 250 ml. Of course, it is faster. But you have to be careful. You can use it only when either you manage the coefficient like this, the way I have done, divided by 2, divided by 3. Akash, you heard about this equation? So you can use it only if you balance the coefficients. Amudita, you write it down because I think you are more into thinking in this. So if you want, you can use it. Okay, so lead phosphate, Akash is giving me the amount of lead phosphate as 12.5. Is he right? I will again start with this 37.5 millimoles of lead nitrate, PbNO3 twice, and I'll plug in the ratio. The ratio is 1:3. So he's giving me the right number, children. But Akash, I'm asking solid. in grams. See, grams. So now you multiply by the molar mass, right? You multiply by the molar mass. But that molar mass you are going to take in milligrams. So molar mass, whatever molar mass is there, milligram over millimole. The way we were calculating earlier by looking at the periodic table, adding the atomic masses. Now only thing is that in place of gram, you will say milligram. Okay, Akash is giving me final answer as 101 grams. It's a big number. No, not 101, 10.1 gram. Okay. Is it right, children? What is the molar mass of this lead phosphate? Did you calculate the molar mass, Akash? Hello? For how long you could not hear me? Okay. My God. Okay, so I was saying, Amodita, if you do this calculation, you are getting this. And this is milligram. That's why this is a big number. Then you are dividing it by 1000 to get grams. Amodita, you are with my calculations? No, then you are doing some error. Did you place a decimal here? This is a big number. How can you are getting only 10? Can you see a big number here? 811.54. So check your calculations. So you should be getting a very big number. Oh, no, no. Yes, that's the error she's doing. Okay, who is going to explain her? I'm going to erase this, Amodita. This answer is correct. I'm going to explain what you are asking. Okay. See here, Amodita. 811.54 gram. Oh, Akash is giving us grams per mole. You convert this grams to milligrams. You convert this moles to millimoles. You know how to do that? you have to multiply by 1000, right? So by 1000, this becomes milligram. This one also by 1000, and this becomes millimoles. Can you see? 1000 cancelled. So it becomes 811.54 milligram per millimole. Just like molarity. Okay, ready for another question, children? Those who are getting confused, participate in the next question. Okay, the next question I'm taking 59. Can see the question 59? So what is the first thing I need to do? Please write here step by step. What should I do first? Make an equation. I'm not going to write net ionic equation, children. Write a balanced equation. That's it. I will break them into ions if they are asking me ionic concentration. We'll do some question based on that. Okay, so I'm going to write the equation. AgNO3 is the reactant. See, reactant. Completely soluble, strong electrolyte. NaBr is the reactant. Completely soluble, giving you double displacement. NaNO3, completely soluble. And AgBr, which is going to be insoluble. Rule number 2 of the solubility rules. Check rule number 2. Otherwise, they are telling you. So in the examination also, they will not tell you rule number 1 and rule number 5, but they will give you hints about other rules. They will write like they are writing here, solid. So that is the reason I said for other rules, you need not to memorize them. But if you can memorize, that will be good. Okay, this equation is balanced, right? Now, they have given the volume. Here I can use M1 V1 equals to M2 V2. Amodita, can you see the moles are same, is balanced, 1:1:1:1. Okay, but here there is a problem. AgNO3 is given to me, NaBr is also given to me. This is a question of limiting reactant. You have done limiting reactants with me earlier. It's a question of limiting reactant. Limiting reactant will give you minimum product. Remember? Minimum product. So let's see who is the limiting reactant. So first, initially when you just starting the reaction, can you work out the millimoles of AgNO3? How many millimoles of AgNO3? See, volume is given, molarity is given. If you remember this equation, millimole is molarity times volume in milliliter. Yeah, it's 15 millimoles. NaBr? 20, okay. NaNO3 initially. Please understand this format of the table. Initial means before starting the reaction, before mixing them. How much NaNO3 before the reaction? Yeah, before reaction, how much AgBr? Now finally, now you convert your 15 millimoles of AgNO3 to AgBr. How much you are getting? How much? 15. Now you convert 20 millimoles of NaBr to AgBr. So who is the limiting reactant? Now from here, check who is the limiting reactant. AgNO3. What happens to limiting reactant finally? Limiting reactant, Mayank, whoever is giving you less amount of the product. Limiting reactant becomes 0. Who is this? Ananya, perfect answer. This gets used up, becomes 0. Yes, Amodita and Mayank. Mayank, your understanding, we are talking about limiting reactant. Now, how much AgB are formed? You calculated. 15. And now this is excess then, right? This is excess. Can you tell me how much excess left? This is limiting reactant. 5 is left. How much NaNO3 formed? Yes, Mayank, very good. 15 is formed. What's the question? Mass of solid AgBr. So, mass equals to, you know the millimoles, right? So, millimoles, which you can convert into moles if you want, otherwise you multiply by the molar mass of AgBr in milligrams over millimoles. It will be the same. Then you can convert, your answer will be in milligrams. Then you can convert that into grams. Amodita is saying 2.81 grams, children. Can you check? Okay, Mayank, good. Amodita and Mayank are very close. The last digit is uncertain, so your answers are good. Okay, good. Anaya. Akash, you are doing calculations? No? Okay, so I'm going to erase this. We have understood. So whenever, please understand this also, write down somewhere in your notebook. Whenever all reactants are given, then the question becomes a question of limiting reactant. Please understand this, write down. If, okay, I'm writing here for you, if amount of all reactants are given, amount of all reactants or two reactants is given in the question, then please focus on limiting reactant, identify limiting reactant, and calculate from the amount given by limiting reactant. Don't use any calculation using excess reactant. Okay, so this is a question which generally children are asking, that how did you come to know that this is a question of limiting reactant? So I checked that they have given me silver nitrate, they have given me NaBr, so maybe one of them is in excess, maybe they are, both of them are limiting reactant, maybe one is excess, one is limiting reactant. So I have to check that first before doing any calculations. Ready for another question? Similar. So you will read the question carefully and you will tell me, is this a question of limiting reactant? Question 57. Read the question, children. 57. It is a limiting reactant question. Very good. For the limiting reactant, Akash, Mayank, you can use LR in my class. Limiting reactant. Yes, it's a question of limiting reactant. But the very first thing, what should I do? What is the first step when I'm starting the question? Write the equation, balanced equation. So what are the reactants? Keep telling me aqueous, solid, everything. Reactants have to be strong electrolytes, aqueous, completely soluble in water. Otherwise, no reaction or not a good reaction. The products are, give me the formula of aluminum hydroxide. Akash has already given the formula. Very good, Akash. Solid plus KNO3. Balance the equation, Ananya. Good. There are two nitrates. Oh, no, it should not be two, it's three. Aluminum has 3 plus. So, should I place 3 here? Yes, very good. Ananya. Perfect, Akash and Ananya. Amodita, where are you? Amodita and Mayank. Amodita, please respond in the chat. You're doing it? Okay. Now, it's a question of limiting reactant. So I'll make the table. Initial, final. So can you work out the millimoles of aluminum nitrate? Okay, very good. 10. KOH. Millimoles are molarity times volume in milliliter. Rearranged equation. KOH is 20. This is initially 0. Okay, Akash has already done the limiting reactant. Girls, move fast. So 10 will give you how many aluminum hydroxide? So we'll convert this into aluminum hydroxide, this also into aluminum hydroxide. And Akash is wrong. Akash, what you did? You are telling me aluminum nitrate as a limiting just by looking these numbers? You will always land up with the wrong answer. Can you check? This many children they do. 10 millimoles of aluminum nitrate can give you how many millimoles of aluminum hydroxide? 10. But you check KOH, 20 millimoles of KOH, plug in the ratio. What is the ratio? 3:1. So 1 over 3. 1 Al NO3, OH. OH3 over 3 moles of millimoles or moles of KOH. So answer is 6.66. Akash, you're understanding this? So why did you say that aluminum nitrate is a limiting reactant? So now please understand one thing. Don't be in hurry of your calculation. Please understand limiting reactant you cannot decide just by looking at the values. You have to calculate every time. In the examination, make it this statement in your head. I'm not going to decide from the numbers given to me. I'm going to decide after doing calculations. Okay, now complete the final here. So you're getting 6.66 of this. How much aluminum nitrate? Left unreacted? 4.4, is she right? Answer then. How you're doing it? So you're going to convert your 20 millimoles of KOH. Now everything, who is the king of the calculations? Remember this word I used to tell you when we were doing limiting reactant. King of the calculation is now KOH. So use KOH, 20 millimoles of KOH, convert that into millimoles of AlNO3 twice. How much? Yes, children, how much is there? Using the ratio, 20 millimoles of KOH times 1 millimole. So that is the one which has reacted, Akash. That is the one which has reacted. How much is left unreacted? Yes, so answer is 3.4 here. Amodita, you are getting it? I'm writing the excess left because I calculated how much has reacted. Reacted is this, 6.66. In fact, 67. Round off. So this should be 3.3. Okay, Akash and Amodita, I'm worried. Are you understanding everything? Okay, what happens to KOH? Tell me, what is KOH now? KOH is 0. How much KNO3? It's 20. Yes. Okay, millimoles. All these are, we are working with millimoles because it's easier. I need not to convert my milliliter to liter. Okay, the question is the mass of solid aluminum hydroxide. So you know how many millimoles are formed. Am I right? So you can convert your 6.66 millimoles of AlOH thrice into milligrams and then into grams. That you know how to do it. Okay, Amodita is saying 0.52 grams. Yes, what about others? Menk? I'm going to make this question very soon complicated. So first let's finish with this. Okay, Mayank and Amodita are very close to their answers. So I'm sure this must be the right answer. Yeah, good. Now children, ready for making this question very complicated? Not complicated. We are learning a different thing now. Please pay attention again. This time, after the reaction, after looking up what all is left and how much is left, you can see everything here. This final picture is there in front of me. My question is, what is the concentration of OH minus, free OH minus in water? Is there any OH minus floating free in the fully dissociated form, or is it used completely? Where? Because all the OH minus from here are here now in the solid. So what's the concentration of OH minus? Nearly zero. Agreed? Nearly zero, because this is going to dissociate a little bit because it's a weak electrolyte. So I'm not going to say that it's completely undissociated. Some amount will be dissociated. So some OH minus will be there. So you can say nearly zero, very less, right? Okay. Now, can you give me the concentration of Al3 plus? Concentration is, you're working with millimoles, your table is in millimoles. So you can use this equation, millimoles divided by volume in milliliter. So can you tell me how many millimoles of Al3 plus are there in the solution, which are not the part of this? Just ignore this one. Very good, Anaya. But this 3.3 millimoles are present in how much volume? No. 250 ml total volume. Now they are mixed together, mixed. Single volume now is 250 ml, right? Please understand this. What mass is formed when this amount is mixed in this amount added. See? So the volume has changed. So what's the concentration? Go only for two significant figures. 0.013 molar. Good. Now very carefully, can you tell me the concentration of K plus in the solution? K plus. K plus you are getting from this KNO3, right? Hmm. Why 6.6? You are checking this one or this one? If you have 20 millimoles of KNO3, how many millimoles of your K plus will be there? Why it is 60, Ananya? You have 20 millimoles or 60 millimoles? Don't multiply this by 3, okay? That's the coefficient of the balanced equation. So the concentration of K plus is from here, because this is the one which is in the water. This is 0 already, right? So this is the one which is there in the water. So it is 20 millimoles over this is the amount given to you. This is the amount which is present over there after the reaction. I think Akash is better in explaining. Check here, Anaya, what Akash is saying. So it's 20 millimoles divided by again 250 ml. How much is this? Okay, we are not taking care of the sig fig because I think it should be 20.0 millimoles because you see all the numbers have 3 sig figs, so it should be 20.0. So this answer should be of 3 sig fig. So 0.0800 molar, 3 sig fig, yeah. Okay, can you work out the concentration of nitrates now? Nitrates. Please be careful. Nitrates are here also and nitrates are here also. So 1 millimole of KNO3 can give you 1 millimole of nitrate. Can you see this is 1:1 ratio? So 20 you are getting from here. 20. Now you have to take care of this coefficient. Amodita, Ananya, see here. How much is left unreacted? 3.3. So 3.3 millimoles of this will give you how many millimoles of nitrate? Look at that. Akash is showing us so nicely. He's a better teacher than me. Yeah, which is, 30. You can work out from here because nitrates are spectators. They are as such on both the sides. So 3 times 10, 30. Isn't it? Divided by 250. And you'll get the molarity of this solution. Up to 3 significant figures, children. 3. So it is 0.11 Okay, 0.119 or 0. It's okay. Both the numbers are very close. Okay, now can you tell me which ions are very high in concentration? Which one? The highest in concentration. These questions are there. Identify which ion will be very high in concentration. Nitrate. Second highest? Second? Oh, aluminum is not. Aluminum is how much? This much? Okay. I think this number is bigger. This one? This one is bigger. This is K plus. This is aluminum. So the highest concentration is of the nitrates, then of the K plus, and then of the aluminum. Minimum is of the OH minus, which is nearly zero, because it was the part of the limiting reactant, which finally has become the part of your weak electrolyte, aluminum hydroxide. So it's precipitated out. You're understanding this language? Can we do one more similar question? Okay. This time I will be speaking very less and you'll be doing more work here. Keep telling me. Read the question and guide me. I will be just writing here, whatever you are guiding me here in the chat. Keep correcting each other if you are wrong. I'll just say that, okay, no, that's not correct. So somebody should correct the other person. Let's do this. First thing, what should I do? Yes, Akash. Write equation. Okay, I'm writing. So Akash is telling me copper nitrate formula. So I think he's right. So I'm writing the way he's saying. Please write aqueous and solid to so that I can know that whether it is a strong electrolyte or weak. What about copper nitrate? This one. Amodita, copper nitrate. Is it aqueous? Solid? What is it? Yes, please. Now do the double displacement. Charges are given here. It's very easy. Just do the double displacement. And I think Anaya has written the complete equation. Anaya, what is the next step after writing the equation? Balance it. Very good. Balance the equation, please. Just tell me the coefficients. Don't write the complete equation. That's going to waste your time. Something wrong, Anaya? This is right, 2 KOH. But something wrong here. Yes, 2 KNO3. Perfect. Amodita, check rule number 5. Rule number 5. It's a weak base. It's a weak electrolyte. It's not soluble. Rule number 5. Okay, so we are clear who is precipitating out. Now, Is it a question of limiting reactant? Oh yes, we have to. Sorry, I didn't check that. We have to because it's copper 2 plus and this is 1 minus. So it should be 2 here. You can correct me also. Okay, now this is initial, final. Is it a question of limiting reactant, children? Okay, so get the information who is the limiting reactant. Complete this table. In terms of millimoles, because I'm working with milliliter, your teacher will not work with millimoles, okay? So don't get confused at that time. Just convert every time your milliliter to liter. And you'll find that this is easier. Is liter? Okay. If it is liter, then I'm going to work with moles. So don't worry here, moles will work because it's given in liters. So how many of copper nitrate? 4 KOH, 6 CuOH twice initially, KNO3 initially. I've written moles here, means I'm working with moles. So I'm not going to write every time. Okay, so you have to convert KOH to CuOH twice and CuNO3 to. Okay, KOH is the limiting reactant. So give me the next part of the table. How much KOH is left? Yes. KOH. Yes. How much CuOH twice is formed? CuOH twice formed? No. Why 6, Meg? 2 is giving you 1. You are going to take this ratio, Meg, isn't it? 2 is to 1. 2 is giving you 1. 6 will give you 3. Meg. How much KNO3? 2 is giving you 2. 6 will give you 6. Ratio. 1 is to 1. You can do dimensional, Meg. How much CuNO3 twice left is excess? How much left? Very good, very fast. Mayank, you are with us? Can you see that how we calculated this one? Now draw a picture. Okay. What's the total volume of the container now in this picture after mixing these two? What's the total volume? So I'm writing here 4 liters. How many copper 2 plus? These are in the solution, right? Aqueous. How many copper 2 plus from this one? From this 1 mole of CuNO3, 1. I'm making 1 from here. Okay, Amudita is asking this question. Anaya and Akash. Mayank, you are not asking questions. Yes. Okay, Amudita, do one thing. As you have seen that KOH is the limiting reactant, so tell yourself KOH is the king of calculations. So you convert your 6 moles of KOH by using dimensional to moles of CuNO3 twice. This is the amount reacted with KOH. You will get 3 here. But the total is 4. So left unreacted is 4 minus 3, that is 1. Menk, you are not responding here in the chat. I'm worried about you. Menk. This is very strongly tested in every exam. Calculate the concentration of the ions. Is there, Menk, you are not responding here. Are you there? What happened? You're understanding everything? If you have some problem, you can stay back in the class. I'll explain you again. Okay, check here, children, this one. So this will be in the solution. This is in the solution. No, it's solid. It's not there in the solution. So I have only one copper 2 plus from this part. From this part, these three are here. So I'm making with the brown color, these three. Okay, it's in the solid form. So they are settled down. 3. That's what they said. Make according to the numbers. Yes, it's settled down at the solid. At solid. Okay, then how much nitrates from here? How many nitrates? Mm-hmm. 2 nitrates. Okay, I'm making these 2 nitrates in the green color. But I'm getting nitrates from here also. How many nitrates from this? 6. So I'm making 6 more. This is how we have to make the picture. 1, 2, 3, 4, 5, 6, 7, 8 nitrates, right? 6 plus 2, 8. How much K plus? This is 0. So how much K plus from here? K plus, children. 6. 1, 2, 3, 4, 5, 6. Is there any OH minus? No, OH minus is totally 0. Okay, now can you work out the concentration of K plus? Concentration of your NO3 minus and concentration of your Cu2 plus. You can always say concentration of OH minus is nearly 0. Okay, K plus is 6 divided by 4. NO3 minus is, how much is NO3 minus? 8 divided by 4. And Cu2 plus is 1 divided by 4. So Ananya, I'm not getting 2 molar for NO3. See, check the number of moles of K plus. There were 6. How much is this? 3 over 2, 1.5 molar. NO3. Oh, I'm getting NO3. Oh, I was looking at copper. Yes, you're right. Sorry. Yeah, Ananya, you're right. I was looking at this. Because it was only 1. See, we calculated. There was only 1, this blue one. In the solution, only 1. From the left axis, the one which is in the solution. We are not going to count these 3 because they are settled here. It doesn't, yes, because the remaining part. Yes, Ananya, very good explanation. Good, Akash, Ananya. When we explain somebody else, we learn better. Make you also try to make other people understand if you are understanding in some better language. Ananya and Akash has given very good explanation to Amudita. Amudita, understood? Okay. So children, these type of questions are there on the website also. And in the next class, I will be finishing with this unit. So I'll teach you about the redox reactions. We have already done acid-base reactions, but I'm going to do some questions here. I'll explain you titration, redox reactions, and questions based on titrations. So these are the simple 2-3 topics are left, which I'm sure that I can cover in the next class. So unit 4 will be done by next class. And I'll upload the test. Okay. Akash is saying he has finished all the unit 3 quizzes and tests. What about rest of you? I think Amodita was doing the test today. But I saw submission from you. Okay. Okay. Redo is totally, you can do a quiz 100 times. More you do, more you will become higher in the ranking. Because I have no problem. You can do 100 times. It's your stamina. More you're working hard, more you'll become, you can be the topper of the group. So how much time you need? Mayank, are you there? Mayank, you have done unit 3 test? So children, can I say I can declare the result on Monday before your next class? Monday morning? Unit 3? Okay. So that's fine, no problem. So we'll declare after Monday. You just need to inform me, Mayank, and because Akash and Anaya, they have, okay, Anaya has also not done. Okay, inform me in the next class when you want the result to be declared. And then we have to start doing unit 4 also, because this is also, these units are small now. Unit 4, unit 5, they're small. So you have to pace up now for doing quizzes. As it is, your summer vacation is also going to be over very soon. So please work hard, and you people are doing really, really good job. You can stay in the class if you have some questions. I'll see you in the next class. Yes, ma'am.